All right, up next we have Darren. Darren is the co-founder and CTO of LLMWare. LLMWare AI is an integrated open source framework and platform for building enterprise grade, LLM applications with a lot of significant partnerships. And love to hear what's the latest here.
Awesome. Thank you, everybody. I appreciate the opportunity. We've got 4 demos to get through and 0 slides. So I'm going to dive right in. All of these demos are actually using Model HQ, which is our no-code agent building platform optimized for the edge. First 3 demos are going to be on a laptop. They're actually a Windows Lunar Lake machine. The last demo then is really a coming attraction. We're actually going to run on an Android phone. So 4 demos to get through. I'm going to dive right in. What you see in front of you is the Model HQ application. All of the demos that you're seeing actually were built using it, and were built with no code. So we'll actually show you the no code and how they were designed as we go through it. The first example that we're going to go through is actually a real life scenario. For those who are on the East Coast, we have had a huge heat wave the last couple of weeks. And about 10 days ago, all of a sudden our air conditioning stopped. So we call an air conditioning repair person, and they stumble behind our air conditioner, which is 20 years old, like in a lot of houses. And the first thing that they do is they start looking to take a picture. So hopefully everybody can see the picture on the screen. They took a couple of pictures looking for key information that were behind our air conditioning unit, model number, serial number, what type of freon it uses, other identifying information, so that they can then either diagnose what they need to do to repair it, what they need to do to fix it, or what machine might ultimately be a good replacement for it. So this triggered for us, we thought it was a great example of the type of agent process that you can build using no code entirely on the edge. So to quickly walk you through this, it took us about an hour to build this process, and the entire process is actually visible. It's what you're looking at on the screen. First is the user input. User inputs 2 images, just like those 2 images that we looked at. Take a picture of the back of a machine, you'd input those 2 images. That's really the trigger to the process. You want to be able to extract, analyze, and start correlating a lot of information that comes out of those images. The next 2 things, the context, we're actually inputting into this agent 2 things. The first is actually a CSV, actually a database table that is a lookup table of all of these models and serial numbers, freon information, the manufacturer data. The second, then, the R22 technical documentation is about a 40-page PDF document that's a technical manual of how to do certain things related to it. All of the other information that you see then in this legend was actually derived as we created the process. And then here is the process that we're going to see in just a second. We build a database table, actually all on our local machine, just captured in SQLite, derived from that CSV, all of that manufacturer data. We then run a vision model against both of those images, asking different instructions, extracting a bunch of information. We then use an extract model to make sure that we've been able to get just the model number. Then once we have that model number, we're actually going to dynamically create 2 natural language queries, insert that model number, convert that to SQL, and then query the database table with the structured information that we need about this, about the type of freon and the serial number for the machine. And then finally, we're going to close up this process with some RAG of, now that we've been able to extract and identify some of this information, we want to run a RAG query to extract some of the key information that's related to this particular machine. That is the entire process that you see on the screen. And now let me go ahead and run it. We're actually going to run this with details. There is a more business user experience where you can see it just at summary. Here, I'm just going to upload these 2 images the same way that any user would upload the images. And then we're going to go ahead and we're going to run the process. Now, what you see here is 3 different models are all being pulled and instantiated on our local machine. Oops, shoot. Hold on, sorry. It did not like the zoom. So hold on, let me try again. I'm going to try this.
This is when we know it's live and real.
It's live, yeah.
You got to have a little bit of the demo gods. Don't worry.
Yeah, let's try this again, and hopefully it won't mess with the screen. All right. So there are 3 models. They're actually being instantiated locally on this machine. One is a vision to text model. The other two are models that we fine-tuned to be optimized for agents for specific purposes. Once those models are actually loaded on the machine, we're actually going to walk through all the steps that we saw in that process. We're building the database table. The vision models then are going to go do their work. You saw what that image was. It was sort of all blurry and had all kinds of information on it. We're going to pull all that information. We're going to extract the model number. We're going to run that SQL query. And at the end, we're going to do our RAG on the technical documentation. So this is running. It'll take just a second. One part of the demo gods that I definitely find is that Zoom consumes a lot of compute resources. So it definitely runs a little bit faster when you're not running it through a Zoom connection. So here we go. The vision model has done its thing. We've been able to extract that model number from the image. We've then converted our natural language query with that model number, queried the database and pulled up the serial number and the Freon type. And then we've actually been able to parse the document in real time, that 40-page document, and then ran a RAG process where we were able to extract information about the key Freon type that was used in this machine. And so that is our full end-to-end process. And then we get a full report of all of the structured information. All of it was triggered by that input image that we provided of the back of an air conditioning unit. We also provide, we don't have time to go through it today, but all the inference history, agent control records that can be set to provide a bunch of different safety parameters, as well as the ability then to output this in a variety of different file formats. We could also then chat with this agent where all that agent state was available. We could start asking natural language queries to it if we wanted to have further interaction with this process. All right, that's demo number one. Now I want to move on to demo number two. You can see how easy it is to build a process like this. I mean, this is the entire process. So let's go on now to the second example. And the second example actually is a shorter one, but it illustrates something that we think is one of the most powerful, really practical paradigms in local edge AI. And that is, how do you do hybrid? Hybrid meaning run certain steps locally, but then at various points in the process, if you need to, be able to punch out to a cloud API-based model. So this process, unlike the last one, it's really just to illustrate how this sort of recipe works and how easy it is to start combining a local model. In this case, a local model that we're going to chat with. We're going to ask it a static command, write a 100-word essay on quantum gravity. And then we're going to pass that output to an anthropic model. And we're going to say, just summarize this in one headline sentence. Now, the example itself is a bit of a toy example, but it illustrates what we believe is a really useful paradigm. You execute a whole bunch of atomic steps, pre-processing steps, post-processing steps entirely locally. And then where you aren't getting the right kind of results or you don't have the right type of capability, you can send all of that out to an Anthropic or an OpenAI and seamlessly integrate it then into the same process and the same workflow without having to do anything unusual. And again, here, this is illustrated in two lines of no code. All right, that's the second example. Now, we could go and run that, but what we can do is actually move into the third example. And in the third example, we're actually going to take this concept of an agent that you've seen can run as an atomic process. It can run with a lot of details with live interaction. It can run in batch mode. It can also run as an API endpoint, so you can programmatically start interfacing with those agents, or you can zip up all the contents of that and send it to another user, and they can immediately recreate and instantiate that agent on their local machine. But what you can also do is what I want to show in the third example, which is you can create custom bots. The idea of a custom bot, we expose 50 different parameters, from the models to the generation to the RAG settings to information sources that you want to package, as well as the ability to start integrating agents into a custom private chat experience. So a lot of times you may want to chat, you may want to be chatting with an information source, but what you also then want to be able to do is to have at your disposal a set of agents that are really tools for common processes that intersect with your day-to-day work. So here is that cloud API agent. I'm going to run it. Again, it was a little bit of a toy example, and this is completely static. It's running in a background thread, so if we wanted to, we could continue to chat. Meanwhile, that agent process is actually running, and all of that output and that state then becomes discoverable in this chat experience. So we just ran that agent that we just looked at, but now seamlessly integrated into a chat experience. We can have a couple of more things like this. And so here's another agent that we can trigger running in the back.
All the time. Could someone please just tell me?
So hopefully you were able to hear that. Hopefully the audio was able to come through. So we were able to immediately convert text to speech. Now I didn't have an opportunity in this demo to show it, but we also have text to image generation capability. So you can do multimedia from vision to text, text to image. You can do speech to text, text to speech. You can work with structured information and unstructured information. You can do all of it locally and running on the edge. Now, one example that I actually wanted to show you, just to set up the next example, is here was something that we actually looked at 3 months ago. We actually ran this and built this with no code. This is an intake process. It's an input from a customer. Could be a WAV file. It could be a PowerPoint file. It could, in this case, just be text that we're pasting into a chat window. And now we're going to go run this intake processing agent that's going to go run in the background. And again, imagine in the context of someone's workday, they may want to be chatting and doing all kinds of other stuff. But when certain events happen, they want to be able to kick off an agent process and have that agent process fully integrated then into their chat experience. All right, so we just went off and did that. This was the output of that process. Just look at it for a second. This is actually going to tie into the fourth demo, which is the last thing that I want to show you guys. A lot more stuff here that we could go through, but what I want to do is flip over to the phone. And again, hopefully you can see this screen. This is an Android simulator. It is a real phone, but it's a little hard to show something on the phone itself. And so I'm going to do two things. I'll do first just sort of that simple example. Write 100-word essay. And so now this model and this code is all running locally on the phone. You can see decent generation speed. This is actually still just running on the CPU of the phone. It isn't even tapping into really the next generation capabilities in terms of the NPUs that are increasingly available on Android phones. All right, but you've seen stuff like that before.
And
People
Darren,
doing chat on a phone.
Darren, what type of let's get into the meat of it. Like what type of phone, Android phone, do you think would this be compatible with or run on? Does it have to be the latest, or
I'm going to answer your question while actually starting the last demo. So again, remember what we just saw, that customer intake process running on the laptop, 5 different models all running, yielding this really structured, nice JSON dictionary. Now we're actually going to run that exact same process running entirely locally on the Android phone. So this is a multi-step agent process with 5 models all running on an Android phone. This is not a state-of-the-art phone. It's probably a middle-of-the-road phone. And this is running just on the CPU. And the phone has about 8 gigabytes of RAM. If you were using a state-of-the-art phone with 12 to 16 gigabytes of RAM, you can run larger models. And a big part of the direction we're going is how do you move from the CPU on an Android phone, where you can see you can do some interesting and useful things, and really tapping into capabilities like the QNN library from Qualcomm, where you can start tapping into all the TOPS capability on the NPU on a phone. Now, what I just showed you on the laptop was a laptop that's been around for about 12 months, tapping into the GPU and the NPU of an Intel Lunar Lake Windows laptop. The TOPS generation capability of Android phones that are coming out over the next 6 to 12 months are not that far off the TOPS generation of that laptop. So really coming back and answering your question, everything that you just saw on the laptop, I would bet in 6 months, we'll be able to run all of that at fairly comparable performance running on an Android phone.